And then they're further broken down into community units, community watershed units. Further down into sub-community units. And lastly, into what we call steward units. And now we can begin to see the complexity of the landscape between these two landowners through these catchments, the valleys, the ridges. And the boundaries of the catchments are used later in the model to locate potential ridge lines and sections of potential path locations in between these two owners. The second contributing input is to identify the signature landscape features. What are the features? Basically, how does the landscape express itself? So by using viewshed modeling, we identified the locations within this region that had the highest view potential. And using the viewshed contribution and input from our conservation partners, we were able to develop a palette of signature landscape features. These include the home places of these conservation partners, the signature landscapes to experience along the way, the peaks, observation points, even potential trailheads. And then these signature landscape features will be used later in the model to help determine potential path opportunities. And the reason why I like signature landscape features, why we call them signatures, is because when people begin to talk about a landscape, they talk about it as views of a certain wetland, even a certain tree. When we've gone into public meetings and we've asked those people, it's a very simple question: bring us your favorite places. What are these places that you love about the landscape? And the results have always been incredibly surprising and equally powerful, which is proved to be in some cases a challenge with GIS. Because, for example, when on one project, we asked this person, what is it you love about this place? What's the signature of this place that makes you want to stay here? And his response was like, well, I don't know. My house is over there, and and I work over here. And I was like, well, how do you get to work? Well, I drive along this one road. Okay. When you drive along that one road and you're driving through that landscape, what are the memory experiences that are triggered as you move through that? And he's like, oh yeah, there's the Farmer Brown's meadow is fantastic. Whenever I drive by it, I can't help but think that was the last place where I landed when I was a smoke jumper. Yeah, and I cannot forget about that. I see that meadow and it reminds me of it. And to me, this is part of that signature of the landscape, how people are connected to it, how they valued it. Unfortunately, a lot of people don't convey these stories and experiences back and forth to each other, so they don't know it. And to me, part of this model is trying to connect those stories together, getting people talking about these special places, because once they understand that this place is also important to somebody else, then that can have a stronger decision on the planners and folks like myself about what to do with those landscapes. So the next contributing input is the parcel contribution, which determines a parcel's potential use in this network. Well, there are a large number of parcels of different sizes that exist between the two property owners. What we have to do is determine which of these parcels is suitable and not suitable for use in this network. And the Okanagan Valley also has an existing patchwork of public land owned by BLM, the U.S. Forest Service, the state DNR, et cetera. These need to get factored into this network as well. And this is really the beginning of the conservation network. And to fill the gaps between these public lands, we need to look at the privately owned parcels. The first step is to identify if there's any existing conservation easements, and then begin to look at the parcels given their size. And the model can be adjusted to select parcels above a determined size within this network. But it's basically if it's a large private landowner, Well, I mean, if you got two owners and there's a ton of private parcels in between the two, and let's say, 75% of them are 10 acres and under, and the rest are large 40-acre tracts and above, well, if you're trying to get these people to talk to each other instead of trying to get 100 different people talking to each other at once, the less number of people initially to get this network going is the best, because given time and resources. Well, the private owned parcels, and this is part of the input that we received by talking to these two landowners and the local land trust, is to also rate what we call a neighbor relationship potential. And these range from yes, probably yes, maybe not, probably not. And these are really judgments based on your neighbors. And what this means is, would this person, based on what they know about them, their relationship with them, what their known values are, would they be interested in trying to participate in this network? Again, this is about trying to focus and make sure that the efforts are well spent. Rather, if I've got a neighbor who's completely in favor of doing something like this and taking down the fences and even potentially doing a conservation easement that bridges both of our properties, if I know that person is interested in that and I know the other neighbor is not, well, I'm going to focus a lot of my time on the one who's in favor of doing this. Lastly, all these contributing features are compiled to create what we call the parcel contribution. This parcel contribution shows the parcels that can and cannot be used in the private conservation network model. And the parcels that can be used are all the public lands, easements, neighbor relations with the values of yes, probably yes, maybe, and that are also greater than 10 acres in size. Parcels that are removed from the model are all neighbor relations with a value of probably not, maybes, and less than 10 acres. The last input to the model is what we call the landscape walkable contribution. And this is developed using 5 different submodels: terrain capability, the linear potential preference, and also what we call dodges, fractures, and route potential. Terrain capability analysis, the landscape slope and aspect, very general GIS analysis. Aspect resiliency is determined by north and south facing aspects, given that north facing slopes receive less direct sun exposure, providing them with soils and vegetation that are potentially more resilient to use. South facing slopes receive more direct sunlight and will potentially require more care and adaptability to use, and therefore should potentially be avoided when north facing alternatives are available. Side slope steepness gives values to different levels of slope, steepness in relation to its side slope walkability specifically, and these steep slopes should be avoided when less steep slopes are available.